Hi class, this is another example of tensional force. Okay, so determine the amount of tension force present in strings if 75 kilogram box is being hanged on both ends, making an angle of 60 degrees and the other end is 55 degrees, both from the horizontal line. Okay, let's illustrate. Okay, the same problem. Let's have the illustration. So it's hanged. Okay, so if I'm drawing like this, so this is the ceiling. Okay, so here is one. Okay, a 75 kilogram box. Most of the time it's a box. 75 kg. Okay, so we have here 60 degrees and then we have here 55 degrees. Okay, so we'll name this as tension 1 and then tension 2. Let's illustrate the free body diagram. Of course, it will need an end. We have this one and then the weight. Okay, so this is T2 and then this is T1 and the weight. So let's draw the components. Okay, so this is your T2 sub Y. Again, we have this 55 degrees here. And then we have T2 sub X. Okay, for the other tension, we have here 60 degrees. And this is your T1 sub X and then your T2 sub X. I mean T1 sub Y. Okay, so let's write the components. Okay, let's have the X components. Okay, X components. For our X components, we have here T1 sub X and then T2 sub X. Okay, and then weight has no component. Okay, for our Y component, components. Okay, so we have T1 sub Y, T2 sub Y, and then the weight. Okay, let's have the values. So T1 sub X is a negative T1 cosine of 60 degrees. And then we have for T2 sub X, we have here T2. It's positive because it's towards east. Cosine of 55. Okay, for your T1 sub Y, you have here T1 sine of 60. It's positive because it's towards north. And then for T2 sub Y, we have T2 sine of 55. And then for the weight, it's directed downwards, so it will be negative m times g. Okay, so we already have the components. So let's now write the conditions for equilibrium. The summation of forces is equal to 0. Therefore, the summation of forces along the x is also 0, and the summation of forces along the y is also 0. Why do we need this? So that this helps us determine that the object is not moving. Then this condition will tell us the amount of the total forces acting in this. Okay, let's just find the total forces along the x. Okay, the summation of forces along the x. So that will be your T sub 1. Again, just add the x component. T sub 1 sub x plus T2 sub x is equal to 0. Okay, so substitute the value. That will be negative T1 cosine of 60 plus T2 cosine of 55 equal 0. Okay, and then let's simplify this. This will be T2 cosine of 55 equal to, this becomes positive, so that will be T1 cosine of 60. Then divide both sides by cosine of 55. Cosine of 55. Cancel. Then we'll have here T2 is equal to T1 cosine of 60 over cosine of 55. Okay, let's just leave it. So we'll use that later. Let's now have the summation of forces. Okay, the summation of forces along the y. Okay, So that will be equal to 0 if we add all the y components. So let's have here, okay, still see that. So that's t1 sub y plus t2 sub y plus the weight equal to 0. Substituting the value, this will be t1 sine of 60 plus t2 sine of 55 minus m times g equal to 0. Okay, so the next thing you have to do is to, okay, move this one, just copy t1 sine of 60, and then let's substitute here the t2. Okay, so this t2, okay, will be equal to this, so we can use this equation. Let's just copy that. That will be t1 cosine of 60 over cosine of 55, okay, multiplied by sine of 55. Okay, so here we still have this sine of 55, equal to, of course, m times g. This becomes positive. Okay, and then the next we have to, of course, simplify this using our calculator. Okay, let's have here the sine of 60, and that is 0.8660. So let's have t1 multiplied by 0.8660 plus, okay, the next one, that will be cosine of 60 multiplied by sine of 55 over cosine of 55, and that is 0.7140. t1, okay, let's have it here, t1 multiplied by 0.7141, okay, equal to, our mass is, let's go back, that will be, what is the mass? 75 kilogram. And that is 75 kilogram multiplied by 9.8 meter per second square. And this will give us, okay, let's have for 75 times 9.8. 735 Newton. 735 Newton. Okay, and then this one will have here 0.8660 plus 0.7141. That is 1.5801. That will be T1 multiplied by 1.5801. Okay, then divide both sides by that. Divide both sides by 1.5801. 1.5801. Cancel, and then P1 will be equal to, of course, that is 735 over 1.5801. And that is 465.16. Again, 465.1604. Okay, I'm asking you to give this so that you can compare later if it's close to the value that we're getting. Okay, so that will be 465.16 Newton. Okay, that will be the value of the tension 1. For tension 2, let's just get this equation. Okay, so we can just substitute here. Okay, here. We can substitute now the value of T1 to this equation. Okay, the equation that we got a while ago for the summation of x. So that will be 465.16 Newton multiplied by cosine of 60 over cosine of 55. Okay, let's see what will be the value of your T2. T2 will be, that will be 465.16 cosine of 60 over cosine of 55. That will be 405.4908. So that's 405.4908. Or T2 is equal to 405.49 Newton. Okay, let's box this one. Oops. So that will be the value of your T2. That's it.